Okay. Hi, everyone. Eric Tongo. I'm the Executive Director of MCN, and I'm chairing this session today, which is dams and collections management. And we have Kit Blanch, database administrator with the Walters Art Museum, and Chuck Patch, right? Correct?
That's it.
And the two of you are going to give your first presentation, and then we'll go to the two other presenters. Okay?
Great. Okay, hi everybody. Thank you for hanging in there with us till the end. The name of our presentation is Give Those Paper Files Legs, Planning and Prioritizing Curatorial Research. My name is Kate Blanch. This is Chuck Patch. Let's see, get this mic going. So this project is based on a planning project that's formally titled Access to Artworks in Encyclopedic Context, but we gave our presentation a snazzier name. This project was supported by an NEH Foundations grant for planning and assessment, May 2013 to May 2015. There is a white paper that resulted from this project, and it is linked in SCED to the program. I don't really have a channel for distributing the white paper otherwise, but if you'd like a copy of it, just come see me after. I can email it to you or put it on Google Drive or something. So about us, I'm the systems manager at the Walters Art Museum. Chuck is an independent consultant for cultural information management, and the Walters Art Museum is in fabulous Baltimore. So a little bit of background about our project. We looked at curatorial documentation that spans about 100 years, and we looked at it trying to plan for digitization and primarily to get intellectual control over the reference resource, if you want to call it that. So gaining intellectual control over the contents in scope, obviously identifying what value they could have to the humanities, not always an easy task. We wanted to prioritize materials and evaluate the technical requirements for digitizing them, and in general, just create a digital strategy that would help us visualize and plan for a scalable, interactive, a scalable, interactive online resource oriented around museum objects in our collection. So on to the stuff, which is really the interesting part. So the stuff we looked at as part of this project included paper-based materials, visual and textual. Why does that keep happening? Sorry about that, guys. Visual and textual documentation that support the Walters collection of art objects. The materials are interesting because they've been produced sequentially over about the last 100 years. First by founder Henry Walters, and then by early museum administrators and the earliest curators at the museum, and then on into present time, our curatorial staff at large. The materials were selected because they not only relate to the art collection, but they relate to each other, and they reinforce each other as a reference resource. And our hope was that when we digitize them together, our reference resource would provide a coherent or encyclopedic look at information around the art objects. So this is an example of some curatorial paper file documents. This category of information includes documentation, research, draft research, published research, unpublished research, correspondence, exhibition planning notes. And because of the diverse nature of the contents of these files, most of the in-depth work did focus around the curatorial paper files. The second item that was part of our project are this set of photographic albums. These are the oldest component of the reference resource. They date from around 1908 to 1927. These albums functioned as a precursor to a modern image-based collections management system. These albums were created at the request of our founder, Henry Walters. He hired a photographer to go through and systematically take a photograph of everything in his collection as it was being kind of brought into the building. And it's pretty much the earliest example of a digital asset management system. And he made multiple sets of these albums. So there's 22 albums in total of installation shots, which are invaluable because we can actually see the ways that he arranged the objects together. So 22 separate albums of installation shots and object images. And the first basic inventory of the museum was apparently achieved by carrying these albums around through the galleries and checking off what was present and what wasn't. Accession numbers, supporting information such as dealer's name, date of acquisition, have been inscribed either on the photographs or on the album pages. And the last component that we looked at as part of this project were our collection catalog cards. So this catalog, we also call them accession cards. This catalog is approximately 25,000 4x6 index cards, and it functions very much like a library card catalog with one card for each object in the collection. A core set of information is included on each card, and the early administrators and curators of the museum would type essentially tombstone information, and they would continue to update the information here. You can see lots of annotations, some of which we know what they mean, some of which we don't. The upper right-hand corner, you can see Gal 579A. That does refer to a location. We don't really know where it corresponds to presently. So the theme of annotations became really big throughout this project, and Chuck will talk a little bit more in depth about capturing annotations. But we do know through this project that we have a lot of them. They're worth preserving, and that our systems don't really do a great job of capturing annotations reliably from source documents. The why. A chronology of reference information about an artwork is a valuable public access resource. I think that's a pretty straightforward why for undertaking this project. But what's a little bit more compelling is historiography, social history or history of interpretations around the artwork. So Merriam-Webster defines historiography as the writing of history based on critical examination of sources or the selection of particulars from authentic materials. For us to be able to activate historiography is a new kind of information for our institution. It's the story of each artwork as a player on our team. It's essentially the modern history of the artwork outside of its art historical world, its country of origin and the artist and who made it and the materials it's made of. We're really conscious that these artworks have a pretty active life as members of our cast. So the how, for a planning grant, we had a very straightforward work plan. The work plan was a lot more granular than what you see here, but we had, a 2-year project. The first year we did a physical inventory. We counted all the pages, all the file folders, all the cards. Not glamorous, but necessary. We rehoused, We rehoused parts of the collection, and then we actually did a second pass, which we called an intellectual inventory, where we sampled 25% of each of the content types and counted documents in different types, really to try to figure out what we had, how much of it we had, and how much of it was going to end up being intellectually compelling. And year 2 was our technical year, so we researched hardware, software, and we looked a lot at the data points we could capture. We looked a lot about how to organize that data, and trying to find a structured ontology or some way to produce structured data out of the information we'd capture. And throughout the whole process, we met collaboratively. Chuck is going to talk about that process more in depth. So with that, I'll hand it over to Chuck.
Okay. Take that, and we're going to do this interesting thing where you switch back and forth. So yes, in the first year, we convened a panel of experts. Actually, we had several panels, but the one that I'm going to be talking about was a panel of content experts, although they'd probably bridle at that term, content. It actually consisted of curators from each of the departments at the Walters, the museum librarian / archivist, who had actually been newly hired, and outside representatives, including art historians and the archivist from another museum with a more established archival program. I came in as a kind of curator whisperer to figure out how it was that these folks actually used these files and why they continued to use them in spite of the fact that they had been largely displaced by electronic and digital sources. So the group met twice during 2013, I guess. I was thinking it was 2014, but I guess it was 2013. First to get an overview of the material that was being considered for digitization, and then later to go over the results of the document survey and analysis conducted by a grant-funded staffer working with the group. And the results of these meetings really varied from kind of the fascinating to the predictable. So fascinating. Some of the most interesting material was actually news to most of the curators, particularly those photograph albums that Kate just showed you from the early years of the museum, and especially the understanding that these albums had actually functioned as a kind of precursor to a collections management system, complete with images. Predictable for nearly all of the curators, although their offices are side by side along a single hallway and the files line the opposite wall of that hallway, they had never really discussed the idiosyncrasies in their specialty areas in a substantive way with each other. The idiosyncrasies that both drove them nuts at the same time that they found those files essential to their work. And fascinating and sort of predictable, although they found the arrangement, the classification by which those files were arranged, that is, by the museum's original geographically oriented departments, they found that a hindrance to usability. At the same time, they felt really deeply that this arrangement captured a significant aspect of the museum's intellectual history, and they didn't want to see it go away. So we go on to the next. So in looking at how these things work, we can start with that last bit about idiosyncrasies in the files. The first thing that became obvious is that some curators found the files tremendously useful in their research. It was the first place to go, as one of them put it. Others regarded the files as kind of a dreary last resort. The difference in attitude turned out to be, predictably, the varying ways in which these things had been managed over the years. So each curatorial division had its own set of files, and these had been managed all along by the head curator in that division. Well, surprise, it turns out that in the divisions where a head curator had held his or her post for many years, the organization of the files were consistent, if outdated. You could figure it out by using the classifications to essentially climb into the head of a past curator. And of course, in the departments where there had been greater churn, the opposite was the case. Incoming curators, instead of totally reorganizing the files, basically tweaked and added to them, gradually introducing a level of chaos that made discovery increasingly difficult. And I just opened my mail instead of moving to the... So following that initial meeting, the project researcher that I mentioned earlier carried out an extensive survey of the files. And this is a list of the broad categories that we came up with and their definitions. And I won't belabor this because it's much easier to look at this table and make sense of it in the white paper that you can download. But seeing the distribution of the file types graphically makes this a bit easier. A huge proportion of the files are just larded with copies of image requests, which are of relatively little interest to the curators, but the vast proportion of the files actually comprise categories of information that are related to the research conducted by curators throughout the history of the museum. And some of this is original, some is duplicated and found elsewhere in the museum in its original form, some is entirely public information in the form of Xeroxed articles from publications. In fact, the proportion of truly original materials isn't really huge, but original or reproduced, there's a considerable amount of information on any given object that's grouped together in drawers just a few steps from the curator's offices, so tremendous convenience. And then we also defined a set of document types that were in abundant supply but were of less interest. And this slide is just a bit of foreshadowing, because if you look closely at these types of materials, they look pretty similar to what we deemed as primary. And teasing out the differences in a useful way led us to a deeper understanding of what was going on with all this paper. So we'll move on to the next one. What it came down to was a kind of evolutionary change that affected the treatment of these materials over time. And the changes could be boiled down to these four trends, each of which built upon each other successively over the years. So the first of these is that was the change from a comprehensive repository to one that was inconsistently added to over time. So this was the direct result of the repository functions really being gradually eroded and absorbed by other tools, some digital and some still paper-based, that were instituted over the years. But the decision of what to add to the files gradually became very quixotic and based on a curator's sense of that something should be kept in physical form, but there was never any well-defined criteria as to what that might be. As a result, that led to, that undercut the browsable nature of these files. Especially as you got closer in time to the present, material was just increasingly sparse. And the curators began to hit these files with highly focused searches instead of actually using them to browse. They just wanted to know if some specific thing existed somewhere in the institution. And with that change in function, the information in the files became increasingly fragmentary, less usable in and of itself, and curators began to use it less as a source of information than as a kind of crude physical gateway to other information throughout the institution. And here's where that ease of use issues expressed itself most strongly, because for the well-organized portions of the collections, the files still retained a bit of their browsable power and pointed to other sources, and that made them a go-to as the first thing. The less organized files, of course, were used by curators searching for any clues that they could find about something that they hoped existed. And that sort of changed things. Anyway, what we gradually began to realize came up was this idea that we labeled residual information. And this is the idea that as information was migrated from one system to another over time, technical constraints at each point where there was a transition resulted in valuable information that was essentially being left behind. And whether it was the images in the albums, the inscriptions and notations on the cards, or the complete exclusion of any unstructured data, which is what ended up in the curatorial files. So, and that prompted curators to keep going back to the files, even though for most things there were better sources of information for them to look at. So there were kind of like two sorts of residual information here. Some of it, I just call it explicit and implicit. The explicit information that was left behind were things like images that were kind of these murky black and white images on the back of the note cards, which told you that that it actually was the object that you thought it was. And because TMS and the current systems aren't fully decked out yet with digital images, these remain the only things that they had to go on. And the second thing were things like the annotations and notations which you could read and that were there for the asking. But then there was also this kind of implicit information. And it was things like the fact that the postscript in the letter on the right hand was handwritten, evidently at the last minute, or that the correspondence was on a certain kind of letterhead, or that the paper was of a light or a heavy bond. This is stuff that scholars, pretty much have always looked at, but that we as technologists sometimes forget or ignore. But it remains important to the curators, and that's one of the reasons they keep revisiting these files. So out of all these realizations, we kind of extracted a set of cross-cutting, or what you might call meta-criteria, that we hope captured some of the residual data, or at least pointed to the search for it that curators were conducting. And just included some of these things here. But throughout this process, there was this really strong interest in retaining the perspective of past scholars, both as it was explicitly expressed in research notes and as it was implied in the classification arrangements that they used. The notes they wrote in the margins of printed publications and the annotations they made to correspondence and work by others. And while we had thought of either transcribing annotations and notes or attempting some kind of OCR, it became apparent after a while that really the realization that it was handwritten was an important question, made us realize that just a simple image was going to do the trick, and it was going to do it better than almost anything else that we could do.
Yeah, so so with that segue, I'm going to jump into some of the technical details. Hardware and software for digitization, I mean, there's a lot out there, and everyone's going to have their own requirements for the kind of tools that works for their institution. One of the things we discovered was because of the high volume nature of the amount of documents that we have, we really needed something that could handle high volume and high quality at the same time. And to date, we didn't have any solution. We have been doing a lot of flatbed scanning of documents, and that while it produces consistent results, it's incredibly slow. The great thing about flatbed scanning is that untrained, non-technician type people can really work on making a good contribution using a flatbed scanner, because you get such a great result, but it is painfully slow. So, we started looking at copy stand technology. So enter the Digital Transitions capture cradle, and they actually were here. I think they had it set up in the exhibitor hall. This thing just changed our whole perspective of what we could accomplish. It's modular. It can handle a wide variety of materials. So this really is what we isolated as needing to accomplish something like this. And it would help us remove the need for a technician involvement at many stages in the process. We anticipate that this is probably going to be powered by a lot of intern and volunteer time, and the more accessible we can make it to that type of help, the better. The other technical piece that is worth talking about is the idea that public access, we moved away from evaluating platforms or content delivery applications, and really tried to start thinking about organizing and preserving these, the data, metadata around these files, so that we could deliver them any which way for any number of years. The primary concept here is that platforms, search tools, applications are constantly evolving. We are not going to be done with this project for at least 5 years, if that. We don't really have a timeline, so why go out and evaluate what's available for us in terms of content delivery? Why not put our efforts towards creating structured data, possibly interoperable data, to really try to, keep the home fire burning. So what we did was we identified the data points in the source materials. We modeled data points together to figure out how they related to each other, and then how they related to a standard ontology. In this case, the CIDOC-CRM works really well because it provides a place for event-based data, which a lot of the data points around our documents are event-based. So the CIDOC-CRM kind of provided the semantic glue that allowed us to get our data strategy documented. And I'm so sorry that keeps flaking out. Anyway, the idea is that the data points get mapped to a structured ontology, and then at any time going forward, applications can be programmed around structured data. So that was a shift for us in planning, but I think it ended up being a better use of our time. So yeah, this is kind of where we ended up, preserving the serendipitous find.
The hope that we could retrieve some of the browsable nature of these files and continue to incorporate their context.
Yeah, that was a quote from one of the curators, and one of the I don't know if it was our humanities expert, but no one can really. We had a hard time identifying the value of the individual documents. The content was really diffuse, but everyone said they could not do without this reference resource because of the potential for the serendipitous find within this reference resource. So our digital strategy really became around just providing a very simple, organized way to access digital surrogates of the documents, and just to see where that led us. The outcome, our project accomplished what we set out to do. We explored a diverse collection of reference resources. We did obtain intellectual control. We understand its strengths. Sorry, it's must be worn out. We did develop a digital strategy that we think supports public access. Besides all that, our key stakeholders decided not to pursue an implementation grant, which was a big bummer. I mean, it's not the easiest thing to find, to reach the end of a planning grant and, have your project be put on hold. We did some post-project evaluation, and the three themes that emerged from the evaluations was that one perspective was that the content within this reference resource is too diffuse. Too much stuff, too much information, too many different types of information, too much junk, too much static. Really the end user felt like they were just gonna drown in, information. And I think what our takeaway from that was we really should have spent more time kind of building trust with end users that we were gonna present a useful, organized, searchable repository of information as opposed to just like, a landslide of digitized documents. The second perspective that emerged in the evaluative interviews was that resources are better spent on other projects, other materials. This is actually, while it's related to the collection as a whole, it's not really anchored in the strengths of the collection, and that this kind of work should be done opportunistically around exhibitions or more focused collection anchored projects. I mean, it's a valid perspective. And then the third theme was go for it. This is an awesome project. It's totally an inevitable place. It's better to start digitizing now. However, that one voice, was outnumbered by the two who didn't want to move forward. So, I think I've tried, Chuck and I have both really tried to present the end. It's not the happiest ending, but I think it's a very realistic ending. And hopefully we'll get a chance to continue working on this, down the road, even if now is not the opportune time for our institution. I did want to just get some feedback from the audience. I don't know how much time we have left.
2 minutes.
Yeah, if we have questions, I had some ideas, questions for you guys. Just are there other materials out there? What kinds of things are in your files?
Deb White from the Brooklyn Museum. I used to be the museum archivist there, and now I'm the digital asset person. So I sort of have both sides, both views. And I think, I don't know if it's parallel to what you saw, but we had tons of documentation in the archives, which was well organized and has finding aids. But then in the curatorial departments, there were files much like the types that you're talking about. And getting curatorial buy-in to do something with those files was really hard.
Yeah.
That, they were really afraid to cede control of them, even though there were incredibly valuable things in there, like letters from artists that any volunteer or intern could, walk off with.
Yeah, and we have had files that have over 100 years of information that are disappeared. We've lost, because they're just lost. So it's.
The model that I like is what the Archives of American Art has done, which is, digitize it all, and it's
Right.
just really searchable, and the utility there is just
That was our initial model.
awesome.
Yeah,
So
yeah.
if we could all do that with our archives, it would be great.
Yeah, Ferris Weber from the Museum, we actually had a project where we had researchers go into our files and transcribe from our historic card catalogs, because the way it happened was it moved from registration, and then they created object files for specific works. And we had a project it was a 6-year project to actually go into the files and transcribe all the material from the files into CMS, into specific data fields that we define. But the question goes back to Archives of American Art, because people want to see the original
Yeah.
document. They don't trust the transcription.
Yeah.
Right.
So you do transcribe it, and they still want to go to the card
Yeah.
catalog and see, I just want to make sure. So
Yeah.
then you go down the rabbit hole of, you have the data, but they don't trust the data, even if the
Yeah.
data has been vetted. So it's a constant negotiation of making staff comfortable with the fact that the information is correct, even though it's been transcribed. There's this level of uncomfortableness with something that is not primary source still, which I find very fascinating.
Yeah.
And I think Archives of American Art is a testament to that, because people still want to see the original document, even if it's a visual source.
Yeah, absolutely.
Any other question?
Thanks, guys.
Okay.
Our next two presenters are Jim Coleman, Manager of Information Technology Business at the University of Arizona, and Joseph Rome, Digital Projects Coordinator for the Center for Creative Photography, and their session is Cloudy with a Chance of Success. Thank you.
I don't know why that was blinking out so often. Hopefully it'll work better for you.
See the mouse, but it's not seeing it. Here we go. Presentation. Start it over. Oh, we got two of them? What happened? Okay, you'll start it over. Sorry. It was just working. It was just working.
25 years.
Let me see.
I know, I know.
There we
Ah, okay, all righty. Good to go. So, welcome to the last presentation of the last session of the Museum Computer Network 2015. Thank you, and well, pretty much, there is something after us, but we are glad you're here. We hope to give you a good show. So basically what we're going to be talking about today in the notion of cloudy with the chance of success deals with the technology transformation that the center has been going on for the last couple of years. So the center itself briefly was founded by the then President John Schaefer, hang on, and as you see, Ansel Adams. It opened in 1975 with the art of the 5 living master photographers, Ansel, Win Bullock, Harry Callahan, Frederick Summer, and Aaron Siskin. Currently, its collection contains more than 130,000 fine prints by more than 2,200 photographers. The archives, because it began as an archive and that's still one of its primary functions, if not its principal function, includes more than 239 collections, more than 5 million individual items. And when I joined the group helping the center, the number was 5 million, and it's now 5 years later, so I'm certain it's more. The center was, this is the current building. It was opened in 1989. It's located at the University of Arizona in Tucson. So the whys and the wherefores of the talk. I want to talk a little bit about the center's IT legacy. I want to talk a little bit about the transition of the center moving from the library to central IT. I'm going to talk about evolving workflows, digitization strategies to manage the collection, and also just simply talk about how the center has begun, or has over the past 2 years, moved most of its material into the cloud, into a variety of clouds. So the reverse Q&A. So how much data do you have? Do you know? Do you know the number of files you have? Do you know the number of file paths? Do you have a good data naming convention? Data duplication. How much duplication do you have? How much data in the aggregate? How do you know that your files are duplicate?
So it's not your computer.
Yeah, I understand that. How easy is it to find? And if you had duplicate data, or it had changed or altered, how would you know? Well, in our case, we basically implemented a system that let us ask questions that could be answered by querying a relational database. So that we, in fact, know at the time of any day exactly the answer to those questions. Now, because we're sort of a techie group here, but an image group there, we're going to intersperse this conversation with images from the center's collection. So until 2013, the library supported the center until it moved under the vice president for research. We had a project that basically took 3 to 4 months to move. Okay, to move the desktops, this was about 50 desktops, 20 terabytes of image and document data from the data center from the library to central IT, and this initiated our thinking about data archiving, storage solutions, backup recovery, and so on. Now, when the center was housed with the library, costs were largely hidden because they were borne by the library. So moving from the library to central IT made the costs visible. And these costs included local storage replication, backup of both documents and objects, servers for the CCP's applications, databases, workflows, timeprints, and the time, of course, to manage all of that, because that does not come itself for free. So in year 1, as you can see, the cost of doing business, and this does not include staff cost, this is simply dealing with the massive amounts of data that the center had at that time. And the center, by the by, is growing its data at a rate of 2 to 4 terabytes a year. Its image data was about $55,000, actually a little more than. So here's another one of the center's images. So this led us to consider, because if you go back and look at this number, the biggest number is image backup. So we said to ourselves, okay, if we can't get backup from the central IT organization, where can we go? So in the first year, we basically put out we undertook a project to identify cloud vendors that could help us. And these are some of the things that we wanted to have them do. And sort of the long story short here is that since the center had no IT staff to speak of, any backup solution would have to be something that could be managed by a savvy IT user. So we weren't looking for people who knew how to write code. We weren't looking for people who were system administrators or database administrators. This would have to be someone who was actually able to to think about data from a user point of view, but a savvy user's point of view. We also had requirements around recovery. For the critical, that's still not happening. For the mission critical information, let's you sort of see here, this sort of the third bullet. So about 300 gigabytes, we figured it had to be recovered within 8 hours. And interestingly enough, in all the vendors that we looked at, only one could do that. So as we did this, as I mentioned, Amazon was not an option at this point. The university was at that time in negotiations with Amazon for a contract, so they were excluded from our consideration. We chose a commercial company called Zeta because they met all those requirements and they were faster by an order of magnitude in backup and recovery. They, however, were as expensive as the local backup source, although they were I think, 20 times better from the point of view of satisfying requirements. They are a very good company, a very good solution, but they're not cheap. So in year 3, we're coming now to year 3. The university has concluded agreements with Amazon, and the CCP was able to look at solutions that would provide some of the main benefits, but at a lower cost. So on campus at the university, we have managed our local storage. So S3 is Amazon's cloud storage device. At the University of Arizona, we have most of our local storage on Isilon, which is EMC storage. And Isilon and S3 are pretty similar, but S3 requires homegrown products, it requires interfaces, it requires active maintenance. In other words, Amazon's platform requires you to have people who can actively do development. Glacier is cheap. Glacier, if you are unfamiliar, is essentially Amazon's cold storage solution. It is very inexpensive. It is, however, as I said, cold storage. If you want to file out of Glacier, you basically file a request, and 4 to 6 hours later, our experience has been 4 is pretty accurate. The file is then placed back into a place in Amazon storage where you can retrieve it. There are costs associated with those. How they are calculated is exceedingly complex. There are costs associated with moving the data as well. That's not so complex. But by and large, if you're using it for cold storage, for backup that you're not expecting to have to go back and get, it's a really very good solution. But as I said, it requires homegrown third-party interfaces, active maintenance. Zeta was a product. Amazon is a roll your own in the current space at the current time. I expect that to change. This is a very rapidly moving environment, and indeed everything I'm talking about today, a year from now, will be different. So we talked about content discovery. So we're moving now into a part of the thing where I'm going to be talking about things that are sort of dam-like. So initially, the center managed its content through file path and naming conventions. Their file naming conventions were actually pretty good. So they didn't begin, when they began doing this, almost everything that they have, they name uniquely. It doesn't mean that that unique file isn't in 5 different places, but at least it has been uniquely named. So we needed something else to capture and manage its file characteristics, metadata, absent a DAM, which would help with a lot of this, and I'll speak a little bit more of that at the very end. We ended up writing software that captures and posts this information into a database, and you saw the SQL queries a few slides back that let us know this. So what do we capture? File name, path, size, date, added, updated. We created an MD5 hash. We have information about Glacier S3 key information, but basically all the information we need to manage the physical aspects of the file and a little bit of information about metadata around the file. The signature creation was critical. this actually is what enabled us to go and move the content, this 18 terabytes from the library, and dump it over in 18 terabytes in central IT. Right? Knowing that whatever process you use, robocopy, fast copy, whatever protocol, to move files from one place to another, you need some way of verifying that the file has arrived intact. And we decided that the thing we needed to do was, in fact, to go to the trouble of doing all this. But the advantage of doing it all is that now we have a system in place that it allows us to either by hand or in nightly scheduled tasks keep our data store refreshed. And we can write logic and have written logic that determines and lets us take other actions as part of that load process, i.e. converting master TIFF files to JP 2000 files and loading the files into S3 and or Glacier. So let's see, we talked about object metadata, we talked about data ingestion. All of this stuff is something that you would want to be able to do as part of a DAMS. And as I say, what we have is a sort of a little mini DAM, I would describe it. But the amount of time that was required for us to do this was significant. And we think that the amount of time to do this, if you're thinking of converting into a DAMS, is going to be equally long, if not longer. So I'm now going to turn it over to my colleague Joseph, who's going to talk a little bit. So I've talked a lot about file management, storage management. He's going to talk about some of the processes we're introducing to change our imaging workflow, change our digitization strategies, in which we think in the coming year will have a dramatic impact on what we're doing.
Thank you, Jim. I guess to start with, I just wanted to say how valuable it is to have a member of our team, such as Jim, an IT professional, who thinks 3- and 4-dimensional. Okay, it's a real asset to have that as part of our team at the CCP. So I'm going to talk a little about our evolving workflows and strategies. Because of the nature of our collection and our archive, there's a variety of materials that we hope to digitize and that we are digitizing and that we have digitized. Sometimes this involves large digitization projects that last months or longer. Sometimes, they could be projects that involve materials that have never been seen. Okay, that could be real important to curators or other museum professionals or scholars as well. We also have our daily digitization efforts, which involve ongoing digitization of recent acquisitions, backlog, things like this that really involve mainly the fine print collection. So we've developed different workflows, architectures for dealing with different types of materials. And in the digitization efforts began at the CCP long before I got there, probably around 2005. 2000, okay, thank you. And sometimes we run into issues with some of the oldest digital assets that we have. And we understand that the imaging technology and specifications and standards for imaging have evolved since that time. And we know that our former colleagues had their best intentions in doing the digitization that they've done in the past. And we kind of call that the sins of the past, but we don't really worry too much about it. We deal with it, and we go on, because we don't want to look so much to the past with regards to our technology advancements. We want to look to the future and prepare ourselves for the future. So enough of that. So an example of a project that we worked on, a long-term project that we worked on at the Center for Creative Photography, and a project that really included true collaboration between different departments. And this was the digitization of the Edward Weston Daybook manuscripts. And there's about 23 manuscripts, I believe. I'm not clear on, it's been a while since I looked at it. But anyway, what you see here are some visual examples of the materials in their cartons. Maybe a part of a manuscript that has been taken out of that container or carton, and then the tools that we use to handle the individual pages of the manuscript. Now this example here, the second image on the top, is Manuscript A that was typed out from the original handwritten manuscript. So there's different kinds of materials. So we have these typed pages, we have these handwritten pages you see down here on the bottom that you used to see at the bottom. I think it just times out. I'm not sure what's going on here, but anyway. So we began to talk about the project with the archivists, and there was a little trepidation about just letting us go through these materials. So we spoke with our conservator, and oh, I see. It's just timing out. Okay. So we worked with Jay Gutierrez, who is our conservator, and she trained us on how to properly handle the materials, which is very valuable. And it puts everyone at ease when we go through training sessions and show that we are very concerned as well about handling the materials. Because the idea here is to digitize these materials so there's a representation of it that doesn't require us to touch the originals. So people can look at the Daybook pages on their monitor through some technology in order to do their scholarly work, et cetera. And so down here on the bottom you see these were actual instruction sessions where we worked with the conservator and put everyone at ease, including ourselves. Then after we went through the training, the whole imaging staff went through the training, and then we began to digitize. At first we have, you can see here the second slide, those are actually silhouettes of our archivists watching us to make sure everything is moving along fine. And they only did that a couple times, and they were like, well, you guys seem like you have it under control. You know, we trust you. Okay, well, that's great. So we're using instant capture technology, which is a tethered 40 megapixel phase 1 camera that's attached to a computer. We're using image science targets to ensure color and tonal reproduction, et cetera. And this project lasted over 6 months. You know, there were thousands of pages, again, handwritten, et cetera. Some of them were two-sided, which required extra handling and extra consideration with regards to show-through from the opposite side of the page, et cetera. So we developed varying techniques to kind of deal with that. And we had a good time. You see how much fun we had. There's people actually smiling at work. So, and it was a true collaboration and very rewarding for me and I know for my crew. And so that's kind of an example. So you want me to take this?
Yeah.
Yeah, so our current kind of post-digitization workflow is we create master TIFFs and their derivatives. And they're placed into an archival storage space, which is basically our local storage. And then we've developed tools that will search nightly or weekly. I'm not sure exactly. I think it's nightly. And it identifies master TIFFs, new master TIFFs that weren't there the day before, and then those are automatically loaded into Glacier. Only the unique files. So, you know, no duplicates, nothing like that. Now, recently we moved to this idea of creating what a smaller archival file from the master TIFFs, which is JPEG 2000. And those are also put into archival storage and then loaded into Glacier S3. And again, only the unique files. We're working very hard to eliminate duplicates, and I think we've done a lot of that, and we don't want to go back to the duplication because it increases our storage costs. Those master TIFFs are then removed from the archival space and only kept in the cloud. And Jim spoke about our requirements of retrieval, which I think is pretty reasonable, especially when considering the bottom line financial savings that we have realized. 2 copies of the JPEG 2000s, 1 archival copy of the TIFF, and the local use copies are created as necessary. So any other derivative files we need for any projects that we have, et cetera. So we worked with a consultant. What a valuable experience that was. I never knew you could talk so much about JPEG 2000. And I never knew that there were so many variables. It was quite a learning experience for myself and for Jim as well. There was, in the past at the CCP, there was talk of using JPEG 2000 early on, and you know, for some reason there was trepidation, and you know, that's a whole different presentation in and of itself. But we had, after testing and working with the consultant and and looking at the files, we came up with specifications for ourselves and what exactly we wanted out of this transformation from master TIFF files, which could be hundreds of megabytes, to JPEG 2000 files, which were significantly smaller. And we identified these specifications. So first off, the files have to open in Adobe applications. It's an industry standard, like it or not. Okay, they had to open. You know, sometimes, I mean, you know, early on we were creating JPEG 2000s with applications and they wouldn't open in Adobe. Sometimes we were creating them with Adobe applications and they wouldn't open in Adobe. So wrap your head around that one. The files must retain all metadata, okay? We apply metadata to individual files, you know, and that metadata changes depending on who the artist is, perhaps, et cetera. The files must also retain all of their color profiles, okay? This is interesting. So what our current workflows, we apply the Adobe RGB 1998 color profile to it. Now, some of the sins of the past, we have different profiles, and those were kind of problematic in transferring to JPEG 2000 because some of the files had other profiles, like printer profiles and things like that the JPEG 2000 engine could not deal with. So there were a handful of images that we didn't or couldn't transfer to JPEG 2000. And then we agreed upon a 6:1 compression ratio with no tiles and precincts. So the emphasis on compression and compression artifacts was done by visual analysis. So we had an array of compression algorithms that we used from 6:1 all the way to 64:1. And it's real easy to see artifacts on a 64:1 compression. Okay, not so easy when you get down to 10:1 or 12:1. So we really had to look critically at the files. And it's real easy to see metadata on a file or color profiles on a file. You know, you can open up or browse the directory in Bridge and see that it's there or it's not there, in a nutshell. I don't know what's going on now. Okay.
Okay.
There you go.
Okay, so sprinting towards the end, just to give you some idea of how long this all took for that amount of data. Moving the master TIFF files to Glacier took 6 weeks, and that's 6 weeks, 7 by 24, pretty much. And I can talk at much greater length about all of this. If you're interested, I'll just go through it quickly. But it's basically kind of linear. Once you've established how fast you can move a file, you just take a look at the amount of data and you say, how many processes can I set off? And because I think Amazon is throttling what it will take as well. At the end of the day, we discovered 250 gigabytes was the maximum we could move in a day, but I could run 4 processes that each did 250 gigabytes a day. So we could achieve a terabyte. Now, part of that all gets into how is your files organized and how do you ship them, and that's complicated. Today, Amazon has a product called Snowball that basically lets you put up to 50 terabytes of data into this queue and ship it off to Amazon and they'll load it for you. Back when we were doing this, the best they could do is 2 terabyte drives, and we said, no, thank you. I don't want to manage 10 2 terabyte drives, the data, the metadata, all that jazz. So as Joseph mentioned, we remove as necessary master TIFFs, and the as necessary is because not every master TIFF that we have can be successfully converted to a JPEG 2000 for the historical reasons that Joseph mentioned. Where we need to, we use the JPEG 2000s to regenerate TIFFs as necessary. So one thing also about the JPEG 2000 format is you can specify, this is sort of a side note, a compression ratio like 6:1, and it can do it losslessly, it will. So 6:1 doesn't necessarily mean lossy, it can mean lossless depending upon the image itself. But in any event, as Joseph said, we felt comfortable with that. So basically, current thing is retrieve master TIFF files from Glacier as necessary. We've done that a few times, principally because we had JPEG 2000s that weren't good. We developed a workflow to support the architecture. We will be migrating to the DAMs when the university adopts a platform, which it has adopted. The university basically said that they're going to sign a contract with Adobe for their DAMs and Creative Suite. So what do we use today? We use Amazon's S3 Web Services, APIs and workflows. We use Kakadu, which is a commercial product, as the JPEG 2000 rendering engine. ImageMagick and other do not do good jobs with JPEG 2000 today. I suspect in the future they will, but this is sort of the industry standard right now. In all of the files that we are generating as TIFFs, we're looking at every one of them, we're adjusting them, we know what they look like. In the case of the JPEG 2000s, we are doing that all in code, programmatically, we never look at them. So what we do is to use an open source program that at least does JPEG 2000 format analysis and determines whether the file that has been created is a valid file. That's a gut check. It's not perhaps the best thing I would like, but we do it. The technology that does all of this is basically Microsoft, .NET technology. SQL servers is the database. We have .NET facing user web pages for some of this, schedule tasks, call jobs to do the ongoing stuff. I'm going to go forward a little bit quickly to the thing that's really important. So I mentioned that first thing. So in year 1, we spent $55,000 on storage. And these numbers are rough, okay? They're not exact. Today, we spend a little over $13,000. So the savings achievement over year 1 is over 40K. This is like 72% savings. But the thing also to remember, this is to the base. This is a savings that we accrue year after year. Of course, we'll be adding more data, and that number's going to go up. No question about that. But with the compression ratio that we have, that first line, JPEG 2000, et cetera, you say 4 terabytes. Actually, it's more like 2. What keeps us awake? Well, long-term viability of JPEG 2000. I mean, it is the case that it's been around for a while. There are vendors that support it, but it's not widely supported. It is, however, a format that is used by a lot of national libraries, so I think that we have some comfort there. There is the so-called catastrophic event. What happens if we have to pull back a lot of data? To be really frank with you, that doesn't keep me awake at night. Because when I look at what Amazon does and the infrastructure that they've built, and I look at my own institution, which has a very professionally run data center, they aren't the same at all, by orders of magnitude. So I'm really not all that concerned about Amazon losing data. Come on. Okay, I worry about continuing to leverage what basically I have built over the course of a number of years. And I think that's going to be changing because, as I mentioned, the university has signed a contract with Adobe. We will be using their dams. But there is certainly the place where there will be things that the Adobe dam does, actually more does not do, that we will still have to be doing. And how much of that there will be, I cannot say. There will be the effort. We will now be moving that 17 to 20 terabytes of data for the 4th time into the Adobe product. So I think we're getting good at it, but still it takes a long time. Okay, so that's in short, I guess I've run over a little bit. And our last slide is this wonderful thing by Louise Delvaux. And if we have time for any questions, I'm happy to answer them. Yes?
So when you move the TIFFs and the JPEGs to the cloud,
Yep.
you say local use copies are created as necessary. Does that mean you take them from the cloud in order to make
No,
them
it means that so basically what we create is we create a master TIFF and we create a crop TIFF and we create a JPEG. We create 3 files. And and from the crop TIFF and so we create 3 files. We then nightly move the master TIFF to the cloud. We create a JPEG 2000. So now locally we have a JPEG 2000, a JPEG, a crop TIFF, and a JPEG. So locally we have those 3 files that we use to do all of the derivations that we need.
And you host those locally?
And we keep those locally, and so what is now 22 terabytes is going to go down to about 4. Yes?
So I'm curious about the sense of the past and whether you learned anything from those that has changed what you're doing now.
Well, yeah, actually, Joseph can speak to that. Why don't you speak to some of the sense? What I can tell you is that because the archival space was also used as a working area at one point in time, we have replications of files that in an archival situation you wouldn't have. Like I'm doing a special project, so I'm going to copy all these directories over here and do my project and then forget to remove them. But there are other things too. So why don't you speak to that?
We operate in the imaging department under strict FADGI standards, so there's not a whole lot we can learn from the sins of the past necessarily, but we recognize them. And I guess one of the interesting things that I learned was the fact that when we were generating the JPEG 2000s, that there were certain types of files or characteristics of files that prevented us from actually being successful in creating the JPEG 2000s for, I don't know, maybe a few hundred or under 1,000 files, I think.
Yeah, because in fact they weren't valid TIFF files.
Correct. So maybe they were 16-bit files or grayscale or 16-bit grayscale files, and they just can't handle that. And again, there were other reasons why that wouldn't work, and those were because they had output color profiles associated with them. So that was a wonderful learning process. Why isn't that working? Well, I don't know. Let's see what's going on with the file. So we analyze it and say, oh wow, all these are 16-bit files. It can't handle it.
Anything else?
Thank you.
Thank you.